Alright, this video is about systems of equations, but in this case we're going to look at linear and nonlinear together. So they don't necessarily have to be lines, they could be anything at this point. So let's look at those. An example, just to give you perspective, is that that means that we might have multiple answers. So we could still have no solution, which means no answers, but we could have multiple answers. So it's not just one anymore. So one such example would mean if I had a circle and a line. Remember, a system is where they intersect. So in this case, they intersect in two spots, so it would have two solutions. Another example is that I could have exponential and a line, and notice these ones don't intersect, and so in this case it would be no solution. So let's look at some examples that pertain to these types of systems. So they give us x squared plus y squared equals 13, and they give us 2x minus y equals 4, and they give us a point 2, 3, and they ask us if that is going to be a solution to this system. So how do I know if it's a solution to the system? Remember, every point is an xy point, and so I'm going to plug them into both equations, and they have to work in both. So for a system to have a solution, that means the at point has to work in both equations. So let's take a look. So the first one, I'm going to have 2 squared plus 3 squared equals 13. And that's what we're asking ourselves. Does that actually work? So we would have 4. 3 squared is 9. Does that give me 13? 4 plus 9 definitely gives us 13, so that one works. But we have to try the second one as well. That doesn't mean, we can't just go with one. So 2 times 2 minus 3, and we're asking ourselves, does that equal 4? So 2 times 2 is 4. 4 minus 3 is 1. 1 does not equal 4. So this one is a no. So when they ask us, is this a solution to the system? Our answer is no. It has to work in both. All right, next example. They give us a system, y equals negative x squared minus x plus 2, and x plus y equals negative 2. They ask us to solve the system. So solving systems works pretty similarly to solving systems of linear that are linear in respect that we can use substitution and elimination whenever possible. So in this case, we can use substitution, mainly because I have a y equals all of this, and it's already set up that way, so then I can plug it into this one. So let's go ahead and do that. I'm going to rewrite the second one, but instead of y, I'm going to put in that top equation. So x plus negative x squared minus x plus 2. And that equals negative 2. And now I can solve it. All right. So combining like terms, x minus x is 0. So we have negative x squared plus 2 equals negative 2. We're going to subtract 2 from both sides. We have negative x squared equals negative 4. Divide both sides by negative 1. So remember, there's a 1 here. Divide by negative 1. So we have x squared equals 4. And then to undo square, we take the square root of both sides. And so we get 2. remember, it's two answers. When I take the square root of 4, it's plus or minus 2. So this is where we get those multiple answers. So we know that our answers always come as an ordinate pair. And so our first one is going to be 2, and the second one is going to have negative 2 in it. So we have two different x's. So how do we figure out y? Well, the y comes from plugging both of those into either one of those equations. It doesn't matter. Okay? So let's first give ourselves some room to work. It doesn't matter which equation we plug it into from our system. We just got to plug it in. All right, so I'm going to plug into the top one. So y equals negative 2 squared minus 2 plus 2. So 2 squared is 4, so we have the negative out there. So it's negative 4 minus 2 plus 2. Negative 4 minus 2 is negative 6. Negative 6 plus 2 is negative 4. There's our first. Now we got to plug in negative 2. So let's do that and see what we get. So we have a negative 2 squared minus a negative 2 plus 2. Negative 2 squared is 4, so we have negative 4 minus a negative 2, so that becomes plus 2, and then plus the 2. Negative 4 plus 2 is negative 2. Negative 2 plus 2 is 0. So what is our solution to this system? Both of these answers. So 2, negative 4, and negative 2, 0. All right, last example. So we have f of x equals 2x, and we have g of x equals 2 to the x power. So in this case, we can also, this one seems a little strange. We can definitely solve it in the same way. We can also graph these. And so if we were to create a graph, we could also see where they intersect, if at all. So let's take a look at the graph of this. Create our coordinate plane here for us to work with. That's y. Okay, so how do we go about graphing these? Well, we can create a table of values for them. So if we are looking at f of x, plugging in numbers for x and getting out values of y. So doesn't matter what we pick, let's just pick some numbers. So I'm going to pick negative 1, 0, and 1 and plug those in. So we'd have 2 times negative 1 gives us negative 2. We'd have 2 times 0 gives us 0. And we have 2 times 1 gives us 2. So here's our points. Negative 1, negative 2, 0, 0, and 1, 2. And then connect the dots the best that I can. Of course, paper and a ruler and graph paper even are great for this. Okay, so now we've graphed that first one. Let's graph the second one. Let's graph g of x. What does that look like? Again, we're going to make an XY chart. This one we might need a few more since it's an exponential. Not so sure, but let's take a look. So let's do negative 1, 0, 1, 2. Let's go with that so far. Again, you just need enough so you can see what it looks like, which is totally fine if you have to add more to your table to keep going. Okay, so that means we're doing 2 to the negative 1. Remember that we flip that. Negative exponents are flipped, so it becomes 1/2. And then 2 to the 0. So anything to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. So now let's plug those numbers onto our graph. So negative 1, 1/2, we're like right in the middle there. 0, 1, 1, 2, and 2, 4. Up here. I think that looks pretty good. There we go. All right, so what is our solution? Good question. Our solution is where they intersect. So had this been drawn on graph paper with a ruler and nice straight lines, we can see that they cross right here. And that point is at the point 1, 2. And I erased the other one, but what we would notice is that when I was filling out this chart that they would have matched. If I plug 1 into f of x, it's 2 times 1 gives me 2. So they both have that same point. So we would see it in the XY charts where they match, but we could also see it in the graph. That's it for this video. So now you'll give me a call and we'll chat about this video and answer any questions that you have. This will definitely be helpful to you as you complete the lesson that follows. Have a great day.